Good morning, everyone, and thank you for joining us today. Today we are going to talk about use a constant scan rate with Horner OCS, and the presentation should last around 11 minutes. As always, if you have any questions, please add them in the question panel, and we will go through them at the end. That said, let's get started.
Hello and welcome to today's webinar. Today we will look at how to use a constant scan rate with Horner OCS. Let's look at our agenda for today. We will do a quick review of what a PLC scan rate is. Then we are going to go into today's topic, which is using a constant scan rate. We will show you how you can lengthen your scan rate along with the describing some scenarios where it is useful. We're going to show you how to do it in a variable-based languages and also with a register-based advanced ladder, and there will be demonstrations throughout, and we will finish with a Q&A session. What is a scan rate or a controller scan rate? It is the amount of time in milliseconds it takes to make one pass through the logic program, and one pass through the logic program covers several different steps, and we have graphically shown them here on the right. You need to read your inputs. This is what the PLC does, or the OCS All-in-one controller. In the case of most Horner products, the controller reads the inputs, then it solves the user logic, writes outputs that needs to be changed, performs some housekeeping, and does it all over and over again. And as an example, your scan rate might be about 2.5 milliseconds for instance. Generally, we think of PLC scan rates or controller scan rates of being constant. In other words, it always takes the same amount of time to go through the program. But that is not entirely true, and there are a variety of reasons why the scan rate varies slightly from scan to scan. Different machine conditions can occur so that different proportions of the logic or different instructions are being executed on a particular scan or in that housekeeping section there, and that is where things are like network connections are taken care of, potentially reading or writing from a memory card. There are a variety of other functions that a modern PLC or a modern controller needs to take care of, which have an impact on the scan, but even most modern PLCs and all-in-one controllers have a scan rate of in the 10 milliseconds or less type range, unless you have a large program or you are dealing with a particular basic controller. Let's talk about lengthening your scan rate to a settable value. In other words, if you just let the controller do its thing, you might have a 2 or 3 millisecond scan rate, but there is a reason why you want that to be longer. Say 10 milliseconds or 30 milliseconds or even 50 milliseconds. Now let's not confuse setting a longer scan rate with time interrupt. What is time interrupt? Well, some PLCs have the capability to set a time interrupt, which is a logic routine, not the entire logic in the program, but a routine that is executed on a fixed periodic schedule. And these were really important when PLCs and controllers had really long scan rates. For instance, like 50 milliseconds was typical, or even 100 milliseconds was also typical. And you had a routine you wanted to make sure got executed at least every 10 milliseconds for instance. So time interrupts were really important, and that ensured that section of logic was scanned much faster than the overall logic. But what we are talking about today is taking what would normally be a shorter scan and lengthen it to a longer one. And why would you want to do that? This is not something you would need to do often, but there are a couple of solutions where setting a constant, longer scan rate can be useful. One example is in process applications, where a longer, consistent interval might better match the timing of the process you are controlling. Now, this does not mean you need to slow down your entire program just to match something like a PID loop. Most PID instructions, like the one from the Horner, let you set your own execution rate independently. So if you want a PID to run every 100 milliseconds, you can do that without affecting the rest of the logic. But where this comes in handy is during a retrofit project. Say you are replacing an older controller with a much faster one, you might start seeing machine sequences acting up or getting stuck. That is often due to race conditions that did not show up before because the old controller's slower scan rate was masking them. Ideally, you would fix those race conditions in the logic. However, when immediate machine operation is necessary, a particular short-term solution is to configure the new controller to match the scan rate of the original. For example, if the previous controller operated at approximately 30 milliseconds and the new one runs at 3 milliseconds, you can apply the technique demonstrated in today's presentation to adjust the new controller's scan rate to 30 milliseconds. How are we going to accomplish that? Well, what we do is we stretch out the logic portion out of the scan rate to what our target is. So if we are looking for about 30 millisecond scan rate, instead of just putting our logic in and letting it execute as fast as possible, we can add a little bit of logic to the end of our user logic where that will be stretched out to a desired level. So that is what we are talking about in today's presentation. So what might have taken 2 or 3 milliseconds would now take about 30 milliseconds. How can we accomplish this? Well, that is what we are going to review today with the logic examples we have for you. But one thing we want to highlight before we get in there is that there are some system registers available in the Horner OCS that you can use to tell what the scan rate is, and the one that is most practical for this application is average scan, which is SR6, and that is the average of the last 5 scans is what the system register will tell you. For our demonstration today, let's start by taking a look at this program, which is a register based advanced ladder, and typically what we would have in our main routine here is this. This is where all our user logic from the existing program would be. So generally, let's say if you have got a 15-year-old program or a 10-year-old program that you are now going to be running on a faster controller, and it runs out that is not executing the way you expected, probably because of some race conditions, then what you're going to do is you're going to add some additional logic to lengthen the scan. So what we have done here is we have left the main loop alone, the main set of the logic alone, and we have added something called a constant scan routine. However, because this is a register based logic, you are going to have to make sure that you do not have any register conflicts between this added logic here and the logic that is already running in the controller that you are adding it to. So almost certainly you are going to need to add or to change these register references here in this example program to make everything work the way it should into some unused register areas. Now there are not a lot of registers that are used by this routine, so there are 6% R's and 2% T's, so not much to it here. So that is not a lot to have to remap in the variable based languages. Here is the logic you are going to be adding again. You will need to remap those 6 registers and those 1 or 2 T bits to unused areas. But what is happening is in this added routine, you are going to say your target scan. Let's say that the program that was running in the old controller was running at 25 milliseconds. Well, in that scenario, you're going to want to set that run to set your target scan rate to 25 milliseconds. The default is 30, so to set it to 25, you would set this move block here with a source of 250 because it is in tenths of a millisecond. So that would need to be changed after you have remapped your registers, and then by adding this routine we have got about 6 rungs. By adding these 6 runs here after remapping and setting your target scan rate, now you are going to have a result of a longer scan rate. Because what this routine is going to do is it is effectively going to be looping until the scan rate matches what it needs to match. Let's take a look at how this works on the bench. Here it is on the bench, and with our example program, you can see we have set our target scan rate 30 milliseconds. We have got an enable bit here, and we have turned on to enable this constant scan rate. And as you can see, we are in the range of 29 to 31 milliseconds continuously. So it is not exactly 30, but it's around 29 to 31 approximately. Now if we were to disable this logic, you would see that the scan rate when it is not in fixed mode, and that is below 2 milliseconds. So you can see how there is a vast difference between having a logic enabled and having the logic disabled. And so if you're trying to lengthen your scan rate for the reasons we have given you, this is a way to accomplish that. Now let's show you how to do the same lengthening of your scan, but this time with our variable based language option, including variable based advanced ladder and IEC. Let's start with the variable based advanced ladder. So what we have done here is we have created a user defined function block here that incorporates all the logic that we just talked about with the register based approach. And so this is the user defined function block that you can import into your project that has 3 inputs. It has an input for linking it to the system register that contains the average scan rate value. It has another input which is your target scan rate. Remember, that is in tenths of a millisecond, and that is another integer. And then we have an enable bit. Now if you were starting with an existing variable based program, the first step you would have to do is to import the user defined function block into your program. How do you do that? Well, you go to the logic modules and you right click and say import logic modules, and then you navigate to the directory that has the UDFB file in it, and then once you have imported that file, it is going to show up here under UDFB modules. It is also going to show up here in your project toolbox under UDFBs that have been imported. Once it is here, then you can drag it into your program like we previously did, and then you can assign your variables to the 3 inputs. Now this is unusual UDFB in that it only has input, it does not have output, but the results will be the same. Once you have set your target scan rate and you have tied the SR variable here and you have assigned an enable bit, then you are good to go, and is going to operate on the bench precisely the way the register based example will. So this is what we need to do for a variable based advanced ladder. Now let's take a look at the IEC. If that is the language you are using, we will take our IEC example here. What we have here is somewhere at the end of our logic, you're going to want to incorporate the user defined function block we have created for you in the IEC format. And here is a structured text instruction for calling this particular user defined function block. As you can see here, we are calling or tying in that user-defined function block to our system register. We are setting constant for the target and we are enabling it through always on bit. This is a very simple way of incorporating that. And then if we take a look at the logic here for our target scan rate, you will see that we have chosen to write this user-defined function block in structured text because it is easy to do so, and it involves looping. And a lot of the times, looping is a scenario where you want to use structured text for that. So here is a routine version in structured text, which is a user-defined function block, which is being called in the main loop module here. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, I'm back. I'm not currently seeing any questions. In this case, let me jump into my screen. Okay, I hope you can see it now. As you can see, we don't have any webinars scheduled over the few weeks. And that's because we are taking a short summer break. We will release the next schedule afterwards and make sure to update everyone by mail once it's ready. And if you want to watch any of the old webinars, you can just use this page and scroll down. You'll be able to see all of them. I'd say that's all for today. Thank you all for your presence, and I hope to see you in the next webinars. Thank you and have a nice day.